Hi, my name is Johanna Stewart, and this is my video report for the fourth lab of Physics 2 on bar magnets. So the purpose of this experiment was to understand more on how magnetism works. We had to measure the on-axis and off-axis magnetic fields that were produced by a bar magnet, and then we had to compare the expected data, which was made computationally, with the actual data that we got. Some key assumptions are that we can approximate the behavior of a dipole of a magnetic field using the dipole magnetic moment, and that the Earth's field is compensated, so there are no external interference on this part. Some preview of the results is that there isn't going to be an inverse relationship between the magnetic field and the distance between the magnetometer and the magnet. Also, our magnitude for the magnetic field off axis is going to be 4.705 times 10 to the negative 5 Tesla, and the B field on axis is 2.716 microtesla. Some fundamental principles are, first of all, Biot-Savart's law, which states that a moving charged particle creates a magnetic field, and also the magnetic dipole moment. We're going to use these two formulas, or we're going to use the first formula more on this experiment, but it's important to know both. So an overview of the system for this experiment, we're going to use setup A and setup B. For the on-axis part of the experiment, we're going to use setup A, and we're going to move the phone, which is a magnetometer, along this, which would be our x-axis, and then for the off-axis experiment, we're going to be moving it along this axis. Our system is going to be the magnetometer and the bar magnet, and the surroundings are everything outside, including the Earth. Some additional assumptions are that our phone is aligned perfectly with the north, and also that there are no other interference from electronic devices in the surroundings. So for the on-axis part of the experiment, as I said, we moved the magnetometer, our phone, closer and closer to the magnet in the x direction. We recorded 5 sets of data. Well, in reality, we did 15 sets of data, but we had 3 repetitions on each distance, and we were able to calculate the magnitude of the magnetic field on the x-axis. With this data, we were able to create this graph. We use the natural log to get a linear behavior because it's easier to analyze, and from this we can say that with greater distance, as r increases, there is a decrease in the magnitude of the magnetic field. Also, we can calculate mu using this approximation right here, and the formula from the magnetic dipole moment. We get that mu is 11.42 joules per Tesla. Now for the off-axis experiment, we first of all started moving our magnetometer until the reading. We started moving the magnetometer along the x-axis until the reading was that the magnetic field was of 100 microtesla, and then we moved the x distance into the y-axis so that we could have the off-axis measurement. It's also important to note that we corrected the y magnitude of the magnetic field because we need to take into consideration the magnetic field created by the Earth. Moving on to the computational model, I input the values for mu and the different observation locations that were done in the experiment observationally, and also d-perp, which was calculated which was shown in the last slide. I also utilized this formula and converted it into a function in order to get the magnetic field at any given position. These are the results. We can see that the behavior of the magnetic field resembles that of a dipole, and the off-axis, the result we get for the magnetic field is of 38.5 microtesla. Some similarities and differences between the computational and the actual data are that our values for the magnet for B off-axis are very similar, but they're not precise. And we can also see that the magnetic field has the same directions on both experiments. And some sources of errors are that the existence of Earth's magnetic field could have affected our results. The magnetometers we used, which were our phones, weren't as precise as others that exist, and also since we had computers and other electronic devices around us while doing the experiment, this could have affected our results. Finally, for the further questions, what if our magnetometer wasn't correctly orientated. This would mean that Earth's magnetic field was affecting our Bx values, and thus our measurements would be skewed. And what if we had two identical magnets stuck together? Well, this would mean a stronger magnet, therefore a stronger magnetic dipole moment, and therefore a stronger magnetic field. So our results would need to be scaled to a factor of 2.